Wildfires scorching Hawaii's Maui and Big Islands have killed dozens of people, left behind smoldering ruins, and forced thousands of residents and tourists to flee. On Friday, the state's governor called it the worst natural disaster to ever hit Hawaii. But how did these fires become so devastating? The cause of the blazes was still not clear days after they began. The fires have hit large parts of Lahaina, a beach resort city of about 13,000 people on northwestern Maui, especially hard. It sits in the relative middle of the 8 main islands that make up Hawaii's archipelago. What experts do know is that conditions were ripe for wildfires there before they sparked off on Tuesday.
Maui was in a D1, D2 severe drought for the season, and the risk for large fire potential was higher there than it was in California.
That's San Jose State University meteorology professor Craig Clements. The National Weather Service had also issued warnings for the Hawaiian Islands for high winds and dry weather. Add to that the unusually high temperatures this summer, in part due to climate change, in part due to the El Nino warming event.
So these conditions all lined up with kind of a classic fire weather situation. It just so happened that there was ignition during the high wind event, allowing a very fast spreading fire to burn into the community towards the coast.
U.S. weather officials say winds from Hurricane Dora have fanned the flames across the U.S. state, coming from hundreds of miles southwest of the Hawaiian Islands in the Pacific Ocean. Separately, a low-pressure system to the west near Japan has also contributed to sustained high winds. These all become a serious problem when they reach Maui's very steep mountain range.
The winds were coming from the northeast, and they were very strong winds. They were descending, going up and over the mountain range and descending what we call the lee side. And when that happens, you get acceleration near the surface. And so you get actually faster winds on the downslope side or the lee side of the mountain range.
Dry vegetation is also a contributing factor. Here's Oregon State University professor Erica Fleischman. She's also the director of the Oregon Climate Change Research Institute.
You can think of it as plants being thirstier, so plants use more water when the air temperature is higher. So the water that is present tends to disappear more rapidly.
Fueling that problem, the spread of flammable, non-native grasses brought in from around the world in areas of former farmland and forest. That's created large amounts of small, easily ignited materials that increase the risk and severity of fire. But what about the next big fire? Hawaiian officials say it will take several years and billions of dollars to rebuild the damage wrought by these fires. But scientists say human-caused climate change, driven by fossil fuel use, is increasing the frequency and intensity of such extreme weather events. Fleischman, the Oregon State professor, says there are ways to limit the risks to homes and buildings, though it's not always easy or cheap.
So many structures ignite because sparks moving far in front of the fire front get into the ventilation system of the building. And there are ways to construct buildings so that the ventilation systems, it's less easy for the ventilation systems to take up sparks. You can have fire-resistant roofs. You can be doing different things with decks, with materials next to structures. So, I mean, there are possibilities for saying a wildfire is likely to happen in the future, but perhaps buildings don't burn down. Perhaps people can protect themselves better from smoke or have better alert networks, evacuation networks. I mean, all kinds of systems to say if we accept as a society that these events will happen again, how can we best protect ourselves and the things we care about from those events?